Okay, stream time. I don't know if I'm prepared or not. We will
Screen
see
time, I
about that.
don't know if I'm prepared or not. I see about that.
That's Kevin for you. Kevin is an open source voice. Sounds kind of like it's been made a long time ago.
I see about that.
Kind of lo-fi. But it's open source so we can run it without the cloud. We should really have some good services that are not reliant on cloud services. It's so weird, this idea of a cloud service. Sometimes you pay them, sometimes you don't, but you are always dependent on this supplier of computation. It's like you don't really own things. And I realized that things like speech recognition are something we really should own ourselves. It makes a big difference when your device itself can understand you, not just by asking a smart server somewhere. So I played around with my Raspberry Pi some more, and I made a nice little protocol. While I was riding the bike, I have this long commute of like 1.5 hours on a bike, and I let this loop run, which registers all the Wi-Fi networks it sees, like every 20 seconds or 25 seconds. And you get this long log file with a date and this network ID, basic service set ID. And when it checks the next time, you get a new list. And then I made a little Java program, which I also ran on the Pi, of course, which analyzes this. It adds minus and plus signs to indicate newly appearing and disappearing networks. And then it makes a condensed log, which is this, with the time and how many networks have appeared and disappeared. You can clearly see when I was moving. This was at the place we hung out with lots of networks visible. And then I started moving and it starts to change. Like basically every second there's a change. And then minute I'm gonna say. Every minute at least there is some change. Then it kind of dies down and you can see that I must have gotten home there. 43, 44, 45, 46, 47. Yeah, this is probably just me switching my phone on and off or whatever it is. Yeah. And then it starts changing minute by minute so you know you're stationary. There's maybe a database out there for Wi-Fi IDs to actual physical location. I don't know. Or we could use this as a basis for learning correlations ourselves. Next thing I want to do is talk to my device. I keep it powered on all the time now. It's in my bag. And I can buy a USB and Bluetooth headset, wear that while I'm riding the bike, and talk to my little smart machine that's in my backpack. Isn't that a cool idea? I can talk to my personal assistant while I'm traveling. Need to get that headset though. Okay, that was the first funny little thing. Oh, and I made the execution of custom code faster on the Raspberry Pi. It now goes to the server for the compiled code. So, because as I said, compiling on the Raspberry Pi is very slow. So now I can do something like here, I can evaluate on the other machine. Well, this is a stupid little example. This would be very fast. I don't know, you get the picture. The idea is that the function is pre-transpiled in the repository. Here, this is the short source code, and the full source code is not much longer. But it grabs this from the website. And then it still does the Java compile, which is also a bit slow. We could outsource that to the server too. Okay, there's something I want to build today though. As always, we are producing stuff. Where's my goal window? This is what we did last time. This time, we rework the voice architecture. What does it mean? It means that we have voice input through a microphone, and we have multiple speech recognition engines that are supposed to run in parallel or after each other. And then we build theories about what the person said. The theory might change as more results of the recognitions come in, and as the logic engine behind that gets to work and makes connections. So different theories may come up about what the system says I said. And we need to reflect that. This is kind of actual work. There's no tool I have right now that makes this happen instantly. This is something I have to code. Okay, but first coffee, right? Yeah, this is one of, some things are fun to code and some things are tedious, I guess. But we have to do this once so we can enjoy our new AI after that. This is the Wi-Fi log analysis program. It's kind of pretty, I'm happy. 50 lines is a good number. This is some other stuff. Finger type mode, this is something I prepare. It's to show buttons on this device which are so big that you can touch them with the finger. So make typing possible. Squeeze the alphabet into 2 screens of buttons. Something like that. And I made a nice lock screen too, which shows the CPU usage. So it's not that boring. I can show that, that's nice. Lock screen. No space on this device. Here. Lock screen. Isn't that cute? Yellow is the Java calculation and blue is everything else. I could watch this all day. In lock mode, because if the touch screen is accidentally touched, it's probably not touched in a way that this button is pressed. Maybe it is, so we could add some more confirmation to this. The touch screen cannot really be disabled. There should be ways to do that. Software. The screen itself cannot be turned off while the device is running. It's a bit of a disadvantage of the Raspberry Pi architecture right now. Or of this specific screen, actually. Okay, back to the complicated stuff. Voice interpreter. Correlator, I think. I had something like that. Speech correlator. Recording start time, end time. That's not so bad. What is this? Voice interpreter? Yeah. Hardcore coding. Morning hardcore coding. So anybody who is not a hardcore coder and a masochist can tune out now while I complete this. Right. What do we want? We want tabs. Actually, I think that's a good way to display this, maybe. Or we just start simple and because we have multiple recordings in flight also. If they say 2 things after each other, both are analyzed in parallel. But that is complicated, right? I'm guessing we could do the simple thing first. Yeah, that actually should make things a lot simpler. Simple version. We can get rid of this here and make it simpler. Yeah, that simplifies a lot of things. Interpretation. This is what any speech recognition gives us. We always reference the current recording. We don't even need this anymore. Yeah, this gets a lot simpler. So we will listen to recordings that come in. Sure. Let's use an example here. Recognize using with AI. It does this. On new recording. Okay. Yeah, we just forget the last one and start new. Let's have a flag here. React to new recording. Not react, do nothing. Recorded where? Yeah, just here. Interpretation. This is like the chosen interpretation. We'll do that later. Yeah. That looks more elegant. We do this later too, though. Start time, end time. Do we even know is the question. We get a file name. Let's start easy and just print things. Everything good here? Yes, looks like it. And we test on the normal machine. Where is here? Oh. Still doesn't handle window resizes very well. Okay, add the new module. Boom, boom. Speech correlator. Man, this is a mess. Put this here. React. I want this React button or checkbox to be visible. Or checkbox React. Aha. And maybe we want to switch editors. Sure, we want that. So we can see both things at once. Okay, react on and off. Oh yeah, let's try to record. Hello world.
Hello.
What is this date? It's probably the end date. Is it not? File date. Modified. Is there a pretty way to show a file date? Render file date. No, there's not, I think. Render file info? Nope. Let's make that render file date, which means modification date. Right. Render local. With seconds. Format local date. What? Oh. Fixed and fixed. Hello.
Hello.
Recording. Yeah, this seems okay. Let's try a longer one. Yeah, no, it's not. This date is when it started recording. That's interesting. And this, the file change date is when it stopped recording. Although file change dates are not very precise. But for now, I guess it's okay. In fact, it doesn't even matter, these two. These are for identifying different recordings. But let's set them anyway. Start time is... No, that's whatever. Ignore this. No, let's do it. Let's have start time. We can use a regular expression. File name. And as we are all good with regular expressions, it's obviously easy to make the right regular expression, which will be digits, namely 8 of those, minus more digits, namely 6 of those. Haha. Let's check that. it worked. Start time, this and that. End time, we skip for now. Keep things simple. Okay, we have a recording. Now we trigger some speech recognitions, right? Trigger speech recognitions. We will have modules for this, like this one. But it doesn't expose its recognition function. It should do this. That would be one way to do it. I don't want to put the recognition in the main correlator module, because these recognitions take time and resources and libraries. Maybe it should really be a separate module to handle the overhead, make it more manageable. That's really important. Okay, let's expose the recognition function itself. Recognize speech. It does some conversion, blah blah blah. Yeah, it actually converts to MP3, which is something we should do in parallel to the regular recording. And see, it's getting complicated already. Some of the speech recognitions prefer MP3, namely the cloud services. Some want WAV files. I'm using the wrong version here. Oh yeah, this one uses the pipelined MP3 encoding, which reduces the latency. Yeah, it's okay. I'm getting, yeah. This relief for now. Yep, file, WAV file, and MP3 file. There we go. That's what programmers are paid for, deciding whether to use an capital F or lowercase f. Well, whatever. Okay, we react to this one, which gives us a WAV file. And we react to this message, which gives us I have a screaming Chinese woman in the background next door. I don't know if I should counteract by using noise cancelling headphones, since I can't make her stop. I think she screams every day. So print have mp3. So the thing is, these two could come in any order. The WAV file could be done first, or the mp3 file, because it's concurrent operation. So we have to correlate those, blah 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 blah. All this little complexity, man. Yeah, this time the recording came first, but it's not a guarantee, I think. Sorry. Recording does come first, but let's make a new one here. Well, I'm editing here again, am I not? This is wrong. Need to edit in this one. Extract state ymd minus strict because it needs all the digits. Yeah, whatever. Oops. Wrong type. So extract. What is this one? This is nothing. Yeah, no, that's the right one. Yeah, we should just clear the results when there's a new start time. That's the clean way, I think. Interpretations. First of all, store them. And just make it a synchronized list so we can operate concurrently. And there was this neat way to serialize the object when we change a list. Modifying list. Yeah, here, this is a cool one. DM synchro list. Yep. Did it work that way though? Let's check. Yeah, you have to initialize it later. I think that's the trick. Yeah. That's complicated. Mm-hmm. I still kind of like it. I'm gonna do it. The structure requires 3 lines to set up, which is too much for my short code tastes. Oof. But wait. This could be simplified though, I'm sure about that. Let's do this one. Two. Okay, set start time. And the idea is that this will clear existing interpretations because they apply to an older recording. Set start time. If there is a change, we clear the interpretations. Yeah, that might work. That might work. This is really tough programming stuff. This is not like, oh, a little idea and I quickly realize it. This is, well, this is hard work. Just with notify. Oh, I know, I just mistyped. Real coffee today, not decaf. Stella, come back here. Test.
Test.
Null pointer exception. Oh, I did it the wrong way. Yeah. Test.
Test.
Have wave. Have MP3. Okay, and each of these are going to trigger different speech recognitions. Trigger MP3 speech recognitions. And wave speech recognitions. Although that just looks stupid. Let's do type. Oh no, not this. Okay. Type is MP3 or wave. Audio file. Oh no, we just put some of them in there. Yeah, we can just scan for modules. Yeah, no, wait. We make the modules announce themselves as speech recognitions. Right? Exactly. Depending on what is loaded. Yeah, exactly. Exactly. Or we can just have the modules do this themselves. Oh, it's really complicated, man. Oh, this is just... Oh. When you design a new architecture, sometimes there's so many decisions. Which module calls which module? First of all, save this. Okay, it compiles, that's good. We could also do nothing here and just wait for the other modules to send their recognitions. That's actually another option. That would be simpler for now. Yeah, they must send something when they're done recognizing. The thing is, they usually put the recognized result up here and make it functional immediately. But we might not want that anymore. That's some sort of flag. Yeah. Okay, first of all, we should send out our recognition result to any interested party. At this point here. Speech recognized. And we provide the module, some short info, and the text, and what we recognized. Now these are a lot of parameters, that's a bit stupid. It warrants a map. Module. Info, text, audio file. Oh, that's pretty good. Okay. Maybe call this differently to indicate that it's just one result that may be wrong. Yeah, let's call it raw. Okay. Yeah, that's elegant. That's good. And here we react to this message. Speech recognized raw. Map something. Yeah, if it's a file that interests us, we just grab the date out of this. Okay, we're getting somewhere. Get audio file. Start time. If it's not for the recording we have in mind, we ignore it. Ignoring speech result for time date. Okay, now we know it's for the right time. Then we add an interpretation, right? New interpretation. This is missing some fields. What's going on? Text, by, and rank. It was called info, I think. Let's stick with info. Text. And info. Rank is not something we use right now. Aha. New interpretation. Total. Some count. I love I as a variable name. Usually reserved for loop counters, but now it means interpretation. This should really be a record though. Which would also simplify this, but we'll stick with that. Longer form. Okay. Check it out. Yes, you got me there. Morning.
Morning.
Okay, someone recognized this speech. Otherwise, we wouldn't see the result here. But why is this message not being sent? Okay, we have loads of these modules loaded. Why do we have two? One is not enabled. Boom, goodbye. This one is enabled, and which one is it? Ten to 6976. Oh, we didn't update this one. Updates are important.
Updates important.
Yeah, cool. We have one interpretation. Very nice. Very nice.
Very nice.
Okay, threw away the old interpretations because we have a new recording. And now we have one interpretation. Cool. Because the magic begins as soon as we have multiple. Oh, we can just yeah, just return spell. Is it loaded though? It is. Is it enabled? It is not. Now it is. Is it compiled? I think it is. Guten Tag.
Guten Tag.
Yeah, because now we have the German and English recognizers competing for the input. Go talk or Guten Tag. We sadly don't get confidence numbers from all these recognizers. The open source products probably can be hacked to do this. It might be nice to have a number here of confidence in this recognition, if the number is workable really, with the hopes that if it's actually German, it's going to have a higher score than this one down here. Might not, I don't know, but we don't get the scores usually. So all we have is the recognition result. And now the logic engine has to figure out whether go talk or Guten Tag makes more sense in the situation. So it's an AI task to be solved. Let's quickly hack in the other ID now, Kaldi. And the other engines here. This also needs to send the message. This one here. Yep, that should just plug right in. And same for the German version. Yep. What else did we use? Deep speech we used. We use I think deep speech is English only so far. I haven't seen a well-trained German model yet, but it's pretty good on English actually. Okay, let's enable them all. Oh yeah, we wanted to stop them from putting stuff up here, which is not confirmed. Like basically this whole code fragment here has been repeated all the time. Let's put that in a fragment. Raw speech recognized. Sorry. F. Yes. Yes. What do we have? A module. Text and info. And an audio file. Katze, that was German for cat, was the name of the intelligent AI assistant. Like last year, the year before last year actually, when I was in a different collaboration. Where do we put this flag? Yeah. Query don't don't apply speech. Recognize speech. Honor global flag. When there is a correlator. Bloop. True that. Okay. Now we use. Now we set this flag in the correlator. The correlator is the central thing that controls speech. So it tells everybody else to step back, basically. Answer to message. This is the one. Yes. Answer to message. And say true. True if enabled or whatever. Yeah, let's do this React. Yes, exactly. Only if we are actually doing something, then we tell everybody else to respect us. How about deep speech? This is also transpiled. And okay, let's update the other modules. Avoid code duplication. It's a good thing. There goes one. There goes another one. My stomach is telling me to put things inside. But I keep coding. I even have time to fix the indent there. This one. And also this one. Blop, blop. Oh, the string thing here is kind of wrong. Well, you can put it here. Swing. Lots of retranspilation. Okay. These are not enabled. We need to enable them. Enable, enable, enable. enabled. Oh, see, they are working in parallel now. One of them gives us partial results also. Cool, now we have 4 interpretations. Why do we have 2 with AI English? What? German. Oh, I lost track. German. Oh, I just didn't transpile that one, I guess. Okay, another test. 1, 2, 3. Okay, this one says English. I think it's just a bug. Yep, I forgot to put the right language in there. Okay, now we have 4 engines running already, competing for the speech input. Sag mal was. Okay, pretty sure that when we have a basic logic engine that sag mal was, which means say something, is a more likely output than Zach Mosher, who's a person I've never heard of, or doesn't exist even. And the local engine agrees in the German case, disagrees in the English case, which is another indicator maybe that this might be correct. I mean, if 2 engines agree, that's a good sign. I do want to note when the speech output came in. Was here to see how fast the engines are. Recognized. Recognition. Timestamp of end of recognition. Recognition, I don't know. Whatever timestamp, I don't care. Okay, let's say received. Received is a good name. Received, and it is now. It would be really cool if we subtract this from the time of the recording. For that, we need to put that into timestamp again. Parse local date, maybe. This here, but also with minutes, and oh, this is getting annoying. I want to have this though. Is there not an easier way? Oh, wait, we can check from the end of the recording. Yeah, that sounds easier. We do not know if it was the MP3 or WAV. Okay, let's hack something in. Time. Audio received. Timestamp. Okay, just hack it in. Audio received now. It's just for stats. Doesn't matter. Minus, let's just subtract here. Now we might see how long it took each of the engines to recognize the audio. Can you hear me? Yeah, that's it. Between 1.3 seconds and 3.5 seconds. Yeah, obviously the cloud solutions were faster, and the locals took a little longer. Yeah. And once again, with the correct language, which is English in this case, the engines agree. With the wrong language, which is German, the engines don't agree. So from here we could start selecting the correct interpretation. Yep, I think I'm happy for now. My stomach needs some new energy put into it. So, see you later.